Hi, everyone. So my name is Jamie Harbin, and I work at the Bedford Institute of Oceanography.
And I'm Dan Kelly. I work at Dalhousie University.
So today we're going to do our second video of our newly developed argoFloats package. So last video, we just kind of gave an overview of the workflow and how you would work through an example. And today we are actually going to dive into an example. So more specifically, we're going to make a TS plot near Bermuda. So this can actually be found on our GitHub page right now, where you'll be able to find the URL after we're complete of the video, and then as well as the sample code as well for the video that we're talking about here.
Good. So it's Dan again. We're speaking to you from Halifax in Nova Scotia. And if you're familiar with the news of Nova Scotia lately, there was a terrible tragedy with a mass murder. And we just wanted to point out that, those people are in our hearts, the families and communities. And if you're interested in supporting those families and communities, the Red Cross has set up a special fund. And you can basically go to redcross.ca and it'll probably be on the first page. It's called the Stronger Together Fund.
So now I will point out again on the GitHub page for our package. Essentially, this is the type of example that we're going to work through. So this particular example is near the Bahamas, but today we are going to look at the Bermuda.
And before we do that, we're just showing you here a temporary web page. There's no reason to put the URL in your mind because it's not going to exist once this video is finished. This is the vignette for the package. And just maybe, yes, skim really quickly through it, Jamie. Jamie's controlling the computer. In a minute, I'm going to control my computer. So the vignette goes through some an overview of how to work with the package. And it has some exercises, worked examples with solutions. And we hope that this will help you in learning. And the other is you can always get help within R. And if you can go back up to the top there, Jamie.
Sure.
And I just want you to show the overview of the workflow.
Sure.
So before I get into this, there's really the steps of processing are as follows. First, you have to get an index file from the server. These files are in compressed form or maybe 30 to 40 megabytes, so they're fairly big. And you probably don't want to do them in your workflow every time you start working. We've written a function called getIndex, and what it does is it downloads that file and analyzes it, prepares it for working in R. And it has a caching mechanism so that if that file is under 7 days old, that's a variable you can change. If it's under 7 days old, it doesn't bother re-downloading it. It just reads the existing one. That's always the first step in working. Now there are millions. I think that will find maybe 2 million profiles. There's not that many argoFloats, but the float goes up and down and up and down. Every one of those is called a profile. And so 2 million entries, and each one of them is a net CDF file that's probably of order 50 kilobytes or 100 kilobytes, something like that. So the next step is always to subset. So we'll be showing you how to get index and then how to subset. Once you've done that, we'll use get profiles and then read profiles and then do other stuff. So really the outline of the video here is just going to show you how to do that. So now I'm going to see if I can share my screen.
So I will stop share.
Thank you. And we're a little new to this, folks, so if it takes us a little while. Okay, so now you can see my screen. You can see that, Jamie?
Yep, I can see it perfect.
Okay, so what we're going to be doing, the first thing you need to do always is argoFloats. You can see it's completing here. So I allowed it to complete. I'm in RStudio. I'm typing in this left window here. That's where we'll be focusing. So the first thing you need to do is to get an index. So to learn how to work with that, you would do this. And the help is coming. Maybe I'll make this big. And this is showing you the help for this. And I certainly won't go through this, but just as a really brief overview, these are the arguments to the function, the parameters of the function is another name of saying that. The first has a default of auto. And what that means is it's going to look first in the US Godai Argo server. And after that, it's going to go to a server in France. And if more servers get added, we may add more. And you can tell the server you want to use. The next thing is the file, and you can say that you want a plain Argo or core Argo, or biogeochemical Argo, or merges between the two. You can also give a destination directory. Actually, as it turns out, all of these are good for us for defaults here. So I'm going to do that, and this will maybe take 3 seconds or something. If the file on my computer were more than the 7 days old, then it would take a lot longer, and a little display would come showing you as it downloaded the data. Now this is an object. I'm just calling it I for index. So an object, and when you type its name, it will reply that it's of type index. There are 3 types. We don't need to really get into that, but if you're good at seeing groups of 3 numbers, you'll see that's about 2.3 million items. So the next thing we're going to be doing is we're going to be constructing a subset. Maybe I'll call that IS, subset of I. And we're going to make a circle around Bermuda. That's true, isn't it, Jamie?
Yes, you're right.
Circle equals, and you have to give a list. Oh, and I could show you the help for that, but I guess I just won't. So I need a longitude from you, Jamie.
Sure, so that is negative 64.7505.
And the latitude?
The latitude is 32.3078.
And what kind of radius would you like me to take?
I think we should do about 50 kilometers.
There we go. So I'll do that. It's going to be very quick, but and just to tell people for the geography that Halifax, Nova Scotia is just about north of that. So our longitude is about negative 63 and our latitude about 43. So that's where we are. If you want to know where Nova Scotia is. So yep, so what it tells you is that it kept 48 profiles. And if I had changed the radius to 100, we would have more profiles. Now, if I look at IS, that's of type index. So we've overridden, people who are good on R will know what's going on here. We've overridden the generic function subset to take a particular action here. And you could say you want a circle. You can specify by a rectangle and specify by a polygon. These maybe are for future videos. Okay, so this is an object. It still has a type index. We've also overridden the plot generic function for this. And so I'll just plot that subsetted index. And you can see here in the center, the kind of brown color is land, and that is Bermuda, and the red, green, oh goodness, they call it blue dots, the blue dots. I'm not colorblind, but I always say the wrong words.
Yeah, exactly.
The blue dots there are all the Argo profiles that were ever in this data set, that were ever within 50 kilometers of the central point. And of course, there aren't any that are very, very close to the island because it's shallow. And argoFloats sort of, I'll say the anthropomorphic word, they want to be in water of about 1 kilometer depth. They have a sort of default depth of about 1 kilometer. So the flows that are going in water of 1 kilometer by some physical reasons, which you could take my course to learn about, you don't want to go up onto the, they don't want to go up onto the coast. So that's why they're not in this 50 meters or 100 meters or 200 meters of water there. Right, so that's that. So the next step that we have to do is to get the list of profiles, and I'll call that pro for get for profiles. And the argument to this is, the first argument to this is the subsetted index. In fact, I can do now pro, and you'll see that it's of type profiles. And this is a bit of a detail, but now it has stored within it some names of local files. Now, I've run this before in regions near this, and so all the netcdfs corresponding to these points here have been downloaded on my computer. And if that were not the case, and if you did get profiles, a little display would come up and it would say, I'm downloading this file and that file and the other file. In this case, it's already downloaded 48 files. Okay, so that's an object, but it doesn't actually have the Argo data in them yet. And to get that, I'll do A for Argo maybe. And I'll say read profiles. That's the next step in the processing. And you read the profiles from
And
profile object.
I think it's important too to do the handle flags.
No, because we've, thank you, Jamie, but handle flags now by default is on.
Oh, okay.
Yeah, and to the listeners, Argo data have flags. Argo data can be pretty faulty. All oceanographic data can be pretty faulty, and the convention in oceanography is to keep the data, but to set a flag saying, don't trust this point. And there's an argument to this get profiles function, which will change all the points that you don't trust into NA values in R. You sort of have to do that because the salinity should be in the range of 30, 35, something like that. And before doing this, there could have been some that are like 10, 15, just some crazy numbers. All right, so now we have an Argo object, and I can plot the, you want a TS plot, don't you?
Yes, please.
So again, we're using now the plot overridden generic, or means specialized generic is another way of saying that. And what it's going to do is it's going to see that A, it's going to check that A is an argoFloats object, which it is. It's going to check the type of that it has. And I haven't shown you that, but the type of that is Argos. And it's going to do something special for that. And what it's going to do is plot a TS diagram. If I had tried that, and maybe the viewer could try this on some other things like on IS, this wouldn't work. It would say, well, you don't have temperature and salinity, because the index only gives time, lat, and lon, and some other things. It doesn't give the actual profile data. So I'll press enter. And there you can see the TS diagram for this region. All the profiles are sort of shown together there. And this is showing conservative temperature and absolute salinity. This is maybe a little specialized, but this is the newer way of looking at oceanographic data. The system also can take an older way for that. I can do, well, Jamie, I think I've done what you wanted me to do, haven't I?
Yeah, you have. This is kind of our goal for this video. And I think I'll just mention that, so in this particular video, we did the subset by circle. We do have other ways that we can subset within this package. So whether it be by rectangle, by polygon, by float ID, institution. So we will be doing other videos about that. So the next video, we're hoping to do subset by polygon. And in particular, we kind of want to look at the isthmus of Panama. That's a hard word to say. But more particularly looking at if we were to have both Atlantic and Pacific waters, how the user would deal with that. And we think that the polygon subset is a good way to do that.
Right, that sounds really good. So thanks folks for listening. We'll talk to you again. And again, my name is Dan Kelly.
And I'm Jamie Harbin.
Great, thanks, and all the best from Nova Scotia.
Thank you.